Okay, next talk will be on the novel strategy to fight multi-drug resistance by multiple drug synergism. It's based on docking and drug design in TRIZ. I'd like to introduce Boris Farber, CEO of Noigel.
Let me introduce our company. This is a startup. Our company was established in 2010 by a group of scientists who study and develop new substances in the medical field. Inversion of Noigel is legion. That's how we created this analogy. Like in legion, a unit of soldiers in the ancient Roman army fighting enemies. Noigel is a group of drugs with synergistic effect. We unite scientists from many countries to solve these problems. And Noigel is composed of several groups of scientists from different fields of science and expertise all over the world. There are two types of solving problems in pharmaceutical research and development. Traditional approach, when research and development based on modern technologies, and non-traditional approach, before to start research and development, we create a new heuristic method of research, and all after that, based on this new heuristic method, we apply classical approach. What method our research is based on? Our research based on principle of multiple synergism, TRIZ. I will tell about TRIZ a little bit later. Actually, this is a theory of inventive problem solving, modern design, and technologies in different fields. TRIZ was created by Boris Farber, starting from 1946. And he generalized patterns in the nature of inventive solutions and distinguished characteristics of the problems in different fields. So over 70 years, it was studied more than 3 million patents, practical experience of thousands of scientists, inventors, history, evolution in different areas of technology and science, getting feedback for solving these 3,000 of problems. And after that, finding general principles, he implemented the idea of TRIZ to solve problem. This is general solving problem in any field. One of his book is Creativity is Science. It's a very famous book. It's translated to all languages of work, and it's available in Barnes & Noble, Amazon, etc. This is basic, but book was published many years ago. Now we go far forward from this time. As I said before, TRIZ is based on patterns of evolution, systematical structure way of thinking, supported by numerous tools. And we have different applications. Even for our case, is what develops software, we name it directed evolutions, which help us to solve problem. TRIZ based on laws of evolution of technical systems. Definitely in this short period of time is unreal to external details, but for instance, if you pay attention, I will give a couple examples of this. Okay. For instance, look at this. All system, according to this, goes from mono to poly. It's one of the law. Not main, but this how system developed. I will give some examples. Another a very important part, increase of degree of system dynamics. System static becomes dynamic. Dynamic system is more efficient than static. Few examples from life. Monobipolar. You see monohull boat, catamaran, and trimaran. And for drilling oil, we have polymaran, many boats connected together. If you look at this, stability of this poly system much more than monosystem. Another example. Two materials combined together gives synergy, steel plus concrete, and you have these beautiful bridges. You have thousand examples when more varieties of element you use, the richer you can create a system. TRIZ has 40 principles. So based on studying millions of patents, it was found only 40 principles to create invention in any field. Nobody found principle number 41. Any item and combination can be used by TRIZ algorithm. We have special algorithm to use this one to solve problems. So our group, we are problem solvers. Our TRIZ expertise. We develop and implement TRIZ in different research and development, bioengineering and rocket space industry for 40 years. Solving inventive problems, sharing success of hundreds of companies and individuals worldwide. I'll show in a few minutes. For instance, using TRIZ was created the first myoelectric hand in the world, and license was sent to developed countries like United States, Japan, etc. In my institute, we created new devices for space projects, Soyuz Apollo, and our project implemented and produced in rocket space industry for different fields, for instance, aesthetic and prosthetics. So our goal to create a problem and to solve problem and after the solve. The one day our teacher get problem with lungs. I sent, it was beginning of 90s, I sent to my colleagues letter all over the world using three networks. One network is TRIZ, because TRIZ is implemented in different countries right now all over the world. Second, I was director of science at the time, Research Center Institute of Prosthetic Design. I was vice president of Russian Medical Society. I used three networks and we get the best scientists on our team. It was the beginning, starting point when we started to develop these ideas of work in pharmaceutical industry. We discussed all this stuff with my teacher, and we created a plan what to do. I will not go in details of this slide because yesterday we had many similar slides for CTC statistics, but if you have any question, I can go through this. I will skip seconds also major causes of deaths in USA compared to antimicrobial resistance AMR deaths, because we get a lot of information similar to this on different form. And how we estimate the situation right now? To survive rate of bacteria's innovation in quotation, faster than rate of new antibacterial drugs development using classical way. So this is time to find another non-traditional way to fight MDR bacteria. Bacteria always has advantage in this fight because bacteria is dynamic system and our drug static system. Static system never wins, never beat dynamic. Whatever you do, finally this new bacteria just adjusted to a new one, it doesn't work anymore. So we decided to use a traditional way, and to use a traditional way, this is a small cartoon. Does it work? And we use as usually TRIZ. TRIZ has ability to go through obstacle using avoiding psychological inertia like we see here. Instead of traditional approach, we solve problem different way. And when we decided to do this project using special algorithm from matrix I just showed before, 40 different principles, it was a few slides ago, was chosen 8 different, and number 13, this number one of this one. I want to show example. So this principle were chosen from this morphological matrix, and one of them I just demonstrate how it works. Number 13, invert actions used to solve the problem. For instance, instead of cooling, object heated, instead of suppressing, enhancing, etc. So it was just the first way with our algorithm. We have special algorithm named TRIZ in TRIZ. An example of this, only one of the small examples, inventive principle inversion, or to do opposite, or the other way around. Instead of killing bacteria, provide comfortable condition, reducing their resistance to harmful factors. Hypothesis. If during treatment of infectious disease, we could eliminate the death of microorganisms, we could eliminate the selection process of resistant strains. The factors of microorganism virulence include both exa and endotoxins and acquired antibiotic resistant factors like beta, example, very well-known example like beta lactamase. The loss of toxin production and antibiotic resistance factors make these bacteria not only less harmful but also sensitive to antibiotics, and it helps eliminate the resistant strain selection process. This was hypothesis. Now, we analyze virulence factors, adhesion, invasion, etc. But we all put most dangerous for life. It was adhesion and secretion of toxins. And the next step, so we are looking for these two virulence factors so far. This red, adhesion and secretion. Adhesion factor is one of these aggressive virulent factor which helps to grow biofilms, as you know. Biofilms formation medium for presence the exogenic aggressive factors, blood, lymphocytes, etc., etc. So this one factor. So adhesion based on biofilms. And second one, the most interesting, the phase of logarithmic growth. If you look at this well-known curve, how it goes, we have lag phase over there, logarithmic this far, second one, stationary phase and death. The most interesting is the phase of logarithmic growth, this second one, when the bacteria are completely provided with nutrients and absence competition with each other. They are not struggling with any external aggressive factors. In this case, they dump the majority, if not all, of virulence factors, including factors of acquired antibiotic resistance, toxin formation, and spend all their resources only for their division and reproduction. So, again, paraphrase, log phase is the most prospective target for action of antibiotics in our study. If you go to next slide where I put enlarge this, we combine two curves. The first is red, is number of bacteria. It goes through these three phases. And we included here also this green one, you see over there, toxin production and concentration. If you look on stage number 2, logarithmic phase, I put oval along with this. In this stage, toxin production tremendously decreased. Let's go to the next one. Criteria for virulence factors and synthesis by bacteria. If it is well known fact that in nutrition starvation medium and in the presence of aggression inducers, I'll just make a list of this. Growth bacteria, no such active. Most of these biofilms are impermeable for antibiotics and resistant to heat and antiseptic solutions. What a strategy? Our strategy, this one of the important slide in this presentation, our strategy is to fool bacteria in order to eliminate biofilms and to destroy multi-resistant bacteria by sending false signal, making them think that there is absence of danger. It will bring to initiation of logarithmic phase, bacterial growth. It is well-known fact that the intensive growth of bacterial mass is log phase does not cause a release of more toxins, virulence factors of cause of formation of biofilm. Based on this phenomenon, we have studied the combination of well-known medication and composition expressed in synergetic effect to simulate growth of bacteria. We have developed a method to stop bacteria toxicity and virulence. If you pay attention to this one, to red on the top, red rectangle, our synergetic composition from well-known drug. And the second, this actually well-known or classical antibiotic, this blue one, blue rectangle. If you combine somehow these two substances, and in this, I will show how it works practically. We made experiments. And here by arrows, we show when we implemented which. This is time in abscess coordinate, in ordinate is log of number of bacteria. And in this particular case, if you make this line horizontal, vertically, you will find time, a distance between these two, it's about 2-3 days after getting enhancers. So after getting enhancers, we give them well-known antibiotics. We analyze a few bacteria where in slide I skip in the beginning with CDC, if you remember. Practically all of them except of one was canary, we didn't practice with this. But impact of growth enhancer of the suppressing adhesive properties of Pseudomonas aeruginosa. If you look at this table, our data shows this line in the bottom is controller, where we don't use enhancers. And this combination in the first column, we have combination in concentration of different enhancers. We name it, to keep know-how, we name it ABCD. And if you look at this, we have different strains in these three columns of Pseudomonas aeruginosa. And if you compare control group with our result, if you take enhancer, let's say A, you not only, for some strains, you not only decrease, you also aggravate the situation. You see this 3.5 compared to 3.4. Similarly, you can find this result with different concentration of B, C, D. We have been working for this many years, use our approach, and our pay attention to this one, what we have. For instance, ABC combination, particular, right? We decrease this value practically more than 2 times. So what is it? It's combination of action enhancers together with antibiotics. So this is how grows in enhancer of suppressing adhesive properties. Okay. Next. So again, I want to return this. If we decrease adhesive property, we decrease biofilms probability to get. Second factor, if you remember, red circle was in a few slides ago. Second factor, Right. This adhesive property, and next one, enhance influence on microbial growth. Again, analyze what we have. We didn't show, to save time, combination of separately enhancer A, B, C, and D, and show just more meaningful. Let's say if this is control group over there, and combination B, C are mono enhancers, the even result were higher in this case in our experiment. And this one, 2.8. And for this particular case, our control, ABC, the best combination, you can compare 2. For instance, for this strain, 2.8 and 6.3, 2.2 and 6.2. So, enhancer influence on microbial growth. So the microbial growth, we expected that virulence factor is supposed to go down. And this we decided to check. So we use petri dishes standards here, and we have different data here. This multi-resistant Pseudomonas aeruginosa, and the center of this. So we put here different antibiotics, and this is in the center, this polymyxin, and is after 3-day growth. If you look at the second slide, we have polymyxin, after this one, and we have amikacin, right? This one, you middle one. So with the enhancer, you see this distance increases. So with enhancer's 3-day growth, it was the first passage. After that, we increase, work with this Pseudomonas aeruginosa, and this is 6-day growth, second passage. And you see, if I read this, it is, I wrote some notes about this. This slide shows the growth completely resistant to all antibiotics. Second passage, to the presence of antibiotics. From sensitive antibiotics, amikacin, left only because polymyxin area exceeded 30 millimeters. As can be seen from the first slide, the way amikacin growth area increases to 30 millimeters. We show it is strong. And the colonies of bacteria have become small and single, not merging into biofilms, like mucous formation. In addition, the characteristic green color, which we had in the previous slide, on the nutrition medium is disappear, indicating the determination of the Pseudomonas biosynthesis of one of the major virulence factors, phycyanin. The following passage is generally repulsed with hand, live with Pseudomonas, polyresistant Pseudomonas infection generally stops to grow on the medium contact with enhancers. Trying to revive the strain on the standard medium has led to a resumption of growth, but maintaining high sensitivity to amikacin and polymyxin, and without expression in the environment, phycyanin, subsequent 5 passages. We go to the next one. Second, we use Acinetobacters. We made the same experiment. And if you see, the slide show the growth completely resistant to all antibiotics, Acinetobacter strain. Preliminary screening revealed a complete absence of growth inhibitor zone to all known antibiotics. In a Petri dish with 2 drives left and polymyxin, amikacin, which were susceptible to all other bacteria strains, 2 passages on standard medium left did not result in changes of sensitivity bacteria. And the second Petri dish showed the result of Acinetobacter 2 passages. The bacterium has become sensitive to polymyxin and moderately sensitive to amikacin. This has been observed after 6 days of culture in the presence of enhancers in this substance. In addition, the figure clearly shows that growth density on Petri dishes with enhancer is significantly higher than control plate. This visual is, in this slide you see there are no films over there, and further Acinetobacter passages in the presence of enhancer were surprising. No longer viable bacterium, and 1 day, 12 of incubations, passage 4, grown in Petri dish, only rare colonies, and the 5th passage generally failed. In parallel to the 5th passage on the environmental enhancers, we tried to make passage on a standard medium. Although the bacteria and they regained its growth to control level after 3 passages, but remain highly sensitive to amikacin and polymyxin for the next 5 passages. Another way, after that, it was a case when, I skip this return to a moment, we had a patient, 40 years He had a patient, 40 years old, male, was diagnosed with active multidrug resistant pulmonary tuberculosis. Patient received first and then second blind drugs therapy according to a WHO criteria. And second line later, this is described second line, used controversial therapy according to WHO. Okay. And in this slide, we show the result application of dropping dosage form of enhancer composition in a patient with MDR TB when our other drugs, including 2 lines and reserve lines drugs, were totally ineffective. The patient was in tuberculosis hospital. His doctor decided to try to save the patient's life and apply enhancer. Moreover, all of these drugs for a long time allowed to intravenous use, which we use for this. The patient received once a day by intravenous drip slowly for 3 consecutive days, which passed after standard treatment to which was previously insensitive after using our enhancers. The patient left much better from the hospital. He felt much better in the middle of therapy course. So left pain, no pain anymore, dry cough and wheezing disappeared. After 15 days, the patient routine chest X-ray, over there, second slide, was carried out. As you can see, there is objective improvement in lesion area and destruction in upper lungs. When a year after the treatment, the patient was no recurrence, and within a year after the treatment, the patient was no recurrence, and he did not get more additional treatment. This we did in vivo. And a new system with synergetic properties from available resources. We have developed pharmaceutical composition from known drugs utilized for other purposes. Instead of killing bacteria, this composition initiates their fast growth, resulting in reduced protection and virulent abilities. The resulting synergistic effect is so strong that concentration of each active component sufficient for growth stimulation is between 1,000th and 1/10,000%. Reform as a result of enhancer bacteria could be quickly killed using known means, where these bacteria had prior resistant form. We are looking for partners and investors for our startup for implementing this MDR new product platform, and we have much more developer for implementing our ongoing research project and finding. Acknowledgement. The research is a result of creative, dedicated, and enthusiastic effort of Noigel LLC scientist team, colleagues, and partners. We thank our colleagues. It's big team. We can put all of them. And we use the words Henry Ford's coming together is beginning, keeping together is progress, working together is success. And we worked many years. At least we tried. We did it. It works. I put here a nice picture of Jack Nicholson. And our contact. This is our phone, site, and emails. I'll put over there. And we have another optimistic vision of a new approach designed for synthesis synergetic drugs. So if you have particular question, you can use our email, our contact. And this product is a product of big team from our company. And we will answer everybody if question not goes beyond of know-how or particular questions. Thank you.
Any questions? Boris, you'll be around the rest of the meeting?
Yes, I will.
Okay, so if anybody has any questions, since we're coming up here on the fire drill, there's an opportunity to get ready for. So again, thank you, Boris, and we have lunch now in addition to the fire drill. Meet back here at 1:30.